Hi students, hope you all watched and liked my previous videos. If you haven't watched them, then please watch them by clicking the I button on top or by clicking the link in the description. Okay students, today we are going to discuss about fundamental theorem of arithmetic. Before that, first recall some fundamental concepts which involved in fundamental theorem of arithmetic to understand better. The first concept is divisible. When do we say that a number is divisible by another number? Yes, you're right. A is divisible by B if we get remainder 0 when A is divided by B. Example, if we divide 6 by 2, we get quotient 3 and remainder 0. Here we get remainder 0, therefore 6 is divisible by 2. Our next concept is factor of a number. Students, do you know what is factor of a number? Yes, you're right. A is divisible by B, then we say that B is a factor of A. In the above example, 6 is divisible by 2, hence 2 is called factor of a 6. If we write 6 as 2 into 3, then we say that 6 is factorized as 2 into 3. Let's recall very important concept, prime and composite numbers. Do you still remember the definition of prime and composite numbers? I hope you all remember. A positive integer having only two factors, 1 and itself, is called prime number. And a positive integer having more than two factors is called composite number. I'm just recalling these concepts briefly, so not discussing in detail about these concepts here. In the previous class, we learned about Euclid division lemma A is equal to BQ plus R. What happens if this R becomes 0? That is, A is equal to BQ plus 0, which gives A is equal to BQ. What is the relation between A, B and Q? What can you say about this ABQ? Yes, you're right. Here, P, Q are factors of A. In other words, we can say that A is factorized as B into Q. Now we will discuss the statement of fundamental theorem of arithmetic. Every composite number can be expressed or factorized as product of primes, and this factorization is unique apart from the order in which the prime factors occurs. Let's understand this concept through an example. Take a composite number, say 30, and this 30 can be written as 30 is equal to 2 into 3 into 5 or 3 into 2 into 5 or 3 into 5 into 2 or 5 into 2 into 3 and so on up to 4 times. Now in this prime factorization we can clearly observe that in all the prime factorizations we can clearly notice that all prime factors are same, and even though they are in different order, the prime factorization is unique. Now let's do some questions based on fundamental theorem of arithmetic. Question number 1. Find HCF and LCM of 72, 108 using prime factorization method. Solution. In this solution, we use repeated division method to factorize 72 and 108. Let's factorize 72. Take a least prime number 2 and 2 3s are 6 leaves remainder 1, it becomes 12. 2 6 are 12. 2 1s are 2 leaves remainder 1, becomes 16. 2 8s are 16. 2 9s are 18. And next prime number 3, so 3 3s are 9. So the prime factorization of 72 as follows. 72 is equal to 2 into 2 into 2 into 3 into 3. Let's factorize 108. So in 108 the unit place is 8, hence it is divisible by 2. 2 5s are 10 and 2 4s are 8. Again unit place 4, so it is divisible by 2. 2 2s are 4, remainder 1 becomes 14. 2 7s are 14. And 3 9s are 27. And finally 3 3s are 9. The prime factorization of 108 is as follows. 108 is equal to 2 into 2 into 3 into 3 into 3. Now we will find HCF. HCF is equal to, what are the common prime factors in the both numbers? So we have 2 in the both numbers, and there is another 2 also common in both numbers, and there is 3 in common in the both numbers, and finally there is another 3 is in common in the both numbers. So multiplying these 4 numbers we will get HCF, that is 2 2s are 4, 4 3s are 12 and 12 3s are 36 is the HCF. Now we will find LCM. So LCM is equal to, first we have to write the common numbers, the common prime factors in the both numbers, that is 2 into 2 into 3 into 3. Now we will write the leftover numbers 2 into 3. By multiplying all these numbers we will get LCM. Can you calculate this? Then don't wait. Do it fast. LCM is 216. I hope you all did correctly. Now we will learn one formula, the relationship between HCF and LCM of two numbers. If two numbers were given, then HCF into LCM of the two numbers is equal to product of the two numbers. You can verify the above sum by substituting the values in this formula. Now we will do another question on this concept. Question number 2. Find HCF and LCM of 12, 16 and 18 using prime factorization method. In this problem also we have to prime factorize the above three numbers and have to find HCF and LCM of the numbers. Let's see the solution first. First we have to prime factorize 12. So take 2. 2 6 are 12 and 2 3s are 6. The prime factorization of 12 is as follows. 12 is equal to 2 into 2 into 3. Let's factorize 16. 2 8s are 16 and 2 4s are 8 and 2 2s are 4. The factorization of 16 is as follows. 16 is equal to 2 into 2 into 2 into 2. Now let's factorize 18. 2 9s are 18 and 3 3s are 9. The prime factorization of 18 is as follows. 2 into 3 into 3. Now we will write HCF. What is the common prime factor in these three numbers? Yes, it is 2. And is there any other common prime factor? No. So the HCF is only 2. Now we will find LCM. For that we have to write what is the common prime factor in all the three numbers? Only 2, that is HCF. Now we have to find, is there any prime factor that is common in at least two numbers? Yes, there is 2 in common in prime factors of 12 and 16. Write that 2. and there is 3 in common in the prime factors of 12 and 18. So write that 3 also. Now what are the leftover numbers? In the prime factors of 16 there is 2 into 2, so write that also. And in the prime factors of 18 there is 3, so write that 3 also. So can you calculate the product of these numbers? And the LCM is 144. I hope you all did correctly. Let's see some points. If there is no prime factor in common, then 1 is the HCF, because 1 is a factor to every number. And the second point is the relation between HCF and LCM of two numbers is not applicable for three numbers. I hope you understand today's concept very well. If you really like this video and found helpful, then subscribe to this channel and click the bell icon. Like this video, then share this video with your friends, because this video may be helpful to your friends also. And don't forget to post your valuable comments here. Finally, thanks for watching.